In this video, we're going to do an asymptote analysis and then graph the curve y equals 5x plus 12 over 2x minus 8. Well, we've got the curve y equals 5x plus 12 over 2x minus 8. So we know that we cannot factor and reduce. We can common factor the denominator, but it doesn't help us to reduce. So we see that we've got a horizontal asymptote at y equals 5 over 2, degree 1 over degree 1 after simplifying lead coefficient over lead coefficient. And we've got a vertical asymptote at x equals 4. And that's because when we set 2x minus 8 equal to 0, we ultimately get x equal to 4. Okay. So now what we want to do to analyze this horizontal asymptote right here, we want to let x have a value that's quite a bit to the left of the only break in the domain and quite a bit to the right of the only break in the domain. Well, the only break in the domain is at x equals 4. So what we're going to do is we're going to let x equal negative 100. And that'll be very far to the left of the only break in the domain. And when we do that, we get y equal to 5 times negative 100 plus 12 over 2 times negative 100 minus 8. Negative 500 plus 12 over negative 200 minus 8 is negative 488 over negative 208. Now, we can determine a decimal approximation for that in order to allow us to compare it with the y value of the horizontal asymptote. Well, this is approximately equal to 2.35. Now, the y value of the horizontal asymptote is 2.5. Okay, it's right over here. It's this 5 over 2. Well, 5 over 2 is equal to 2.5. So since we're below that horizontal asymptote to the far left, we can say that as x approaches negative infinity, the curve approaches the asymptote, the horizontal asymptote, from below. Okay, now we can continue on with our analysis, and we can let x equal positive 100. Well, when we do that, we get y is equal to 5 times 100 plus 12 over 2 times 100 minus 8. And we get 512 over 188. And a decimal approximation might be helpful here just to allow us to get a sense of what that number is equal to. It's roughly equal to 2.72. Well, 2.72 is greater than 5 over 2. So what that means is that as we approach as x approaches positive infinity, the curve is approaching the horizontal asymptote from above. Okay, so that's going to be useful information when we ultimately go to graph our curve. So the curve approaches the horizontal asymptote from above. Okay, so now let's take a look at what our curve might look like. We've got remember we're dealing with y equals 5x plus 12 over 2x minus 8. And we've got we're approaching our horizontal asymptote from above to the far right. Whoops. We're approaching our horizontal asymptote from above to the far right. That's not the best. And we're approaching it from below to the far left. Okay. So now we have that information. Let's take a look at a vertical asymptote analysis. Well, we've already shown that our vertical asymptote is at x equals 4. All right, good enough. So what we want to do now is let x equal 4 plus epsilon and let x equal 4 minus epsilon. If we let x equal 4 plus epsilon, then we see that y is equal to 5 times 4 plus epsilon plus 12 over 2 times 4 plus epsilon minus 8. Well, this is equal to 20 plus 5 epsilon plus 12 over 8 plus 2 epsilon minus 8. This is equal to 32 plus 5 epsilon over 2 epsilon. Now, what we've got here is a numerator that's positive, 32 plus 5 epsilon. The 5 in front of the epsilon doesn't really have any impact because epsilon is infinitesimally small. In a sense, it's like putting 5 in front of infinity. You're not going to make it any bigger. So putting a 5 in front of an epsilon is similar in a sense. It's 32 plus an infinitesimally small number. So our numerator is still going to be essentially 32. But our denominator is 2 times epsilon. Now, that's an unimaginably small number. So if I take 32 wholes, 32 of them, and I divide them by 2 epsilon, when I say wholes, I mean wholes like with a W in front. If I take 32 whole numbers and divide them by 2 epsilon, I'm taking a finite value of 32 and dividing it by something unimaginably small. What happens is that's an unimaginably big number. Imagine, if it helps you to think of it, of 32 over an unimaginably small number. Well, you get the idea that what you would ultimately have is essentially infinity. So what we can say is that our to the right of x equals 4, y approaches infinity. And we can show that on our curve. And similarly, now we're going to let x equal 4 minus epsilon. Well, we have y is equal to 5 times 4 minus epsilon plus 12 over 2 times 4 minus epsilon minus 8. We get 20 minus 5 epsilon plus 12 over 8 minus 2 epsilon minus 8. When we simplify this, we end up with 32 minus 5 epsilon over negative 2 epsilon. Now, the numerator, 32 minus 5 epsilon, that's like saying 32 minus 5 times 0.00000000, etc., as long as you could possibly go. Well, that's still going to essentially be 32. Our denominator is going to be unimaginably small. Now, remember when we said 32 over an unimaginably small number is essentially infinity? Very good. That's what we have here. We have 32 over an unimaginably small number. But remember that epsilon is always positive, so negative 2 epsilon will be negative. So if you look back up in the top right, where I've got that 32 over circled, that's like putting a negative sign in front of that. That's going to make it negative infinity. So we're going to have a unimaginably large magnitude number, but it's going to be negative. So what that tells us is that it says that to the left of x equals 4, y goes to negative infinity. Okay? So now we have a sense of what our graph looks like. So just to finally, to put a nice little cherry on top, what we can do is figure out our x and y intercepts. And that's going to give us oftentimes a nice little sense of what the curve looks like in between. So what we're going to do is we're going to let x equal 0. When we do that, we get y is equal to 5 times 0 plus 12 over 2 times 0 minus 8. That's 12 over negative 8, or in other words, negative 3/2. So we have a y-intercept of 0, negative 3/2, which is right about here. And then also we we want to let y equal to 0. Well, this would imply that 0 is equal to 5x plus 12 over 2x minus 8. Multiplying both sides by 2x minus 8, we would get 0 equals 5x plus 12, ultimately getting x is equal to negative 12 over 5. And that's equal to 2.4. That's right here. Okay, so now what we have is a sense of what one part of our graph looks like. And we do our best job graphing it. It's kind of hard on the pad that I'm using, but oh, that's not great. It might be a little easier on whatever sheet of paper you've got that you're using. Might be a little easier to do than on this pad. Yikes. But we'll try to make it look a little bit nicer than that. And then over here, we'll try to make something that's roughly proportional to that. The pad that I'm using isn't as easy to use as a sheet of paper, so do your best to make a quality graph there. And that's the end of this slideshow. Hopefully it was informative for you.